take it away.
Sure. Thanks, Kevin. Good afternoon, everyone. Thank you for coming. I know that the first session after lunch is usually the time that everyone falls asleep. I think the good thing about doing this conference virtually is that I can't see any of you fall asleep. So I'm going to pretend that you're all wide awake and paying attention. If that's not the case, please don't tell me. I'm not interested. I'd far rather continue with my rose-tinted glass view that you're all here and present and correct. So today I'm going to talk about our journey towards continuous deployment, and I promise that I will explain what it means to Coddiwomple. A little bit about myself. I'm a senior principal software engineer at Cardlytics. What does that mean? It means that I mostly write software. It means that I guide our development teams. It means that I mentor our development teams. In addition to being a software engineer, I'm also something of an Agile champion. I've been very fortunate to be working in the Agile space since maybe early 2004. So I wouldn't say that I was in on the ground floor of the Agile movement. But I've been working with it for a very long time, and so the principles have become, fortunately, second nature to me. In addition to thinking about this from an Agile perspective, I've also become something of a continuous deployment champion. And what that means is that I'm looking specifically at the engineering processes and practices that actually enable us to deliver software on a reasonably continuous basis to our stakeholders. So there's a list of things that I'm going to talk about today. As I said, I'm going to explain what on earth a Coddiwomple is. We're going to talk about the landscape of what Cardlytics looks like, so a brief explanation of what we do and where we started from. We're going to talk briefly about the OODA loop and how that's relevant to everything that we're trying to achieve. And then we're going to walk through some of the history of where Cardlytics started with their continuous deployment journey and how we moved forward from there to where we are today and to where we're going tomorrow, because this is a journey that's not complete. It probably never will be complete. It's like the definition of any piece of software. It's never actually complete. So Coddiwomple, what on earth is that? It's an English slang word. It means to travel purposefully towards an as yet unknown destination. I first heard this maybe a year ago, and it was a word that I immediately fell in love with because I felt that it actually exemplified pretty much everything that we're trying to do with Agile. So Agile is a purposeful set of practices. You know, we don't just jump in and start laying down code, or we don't jump in and start building a product without at least having a general direction of where we're going with it. But at the same time, we have a fair amount of uncertainty. We know we're going in generally the right direction, but we may not know that we're going in exactly the right direction, and we may not even know where the actual destination is. So while this picture may give you a little bit of an earworm, there's also a point here that in the way that Cardlytics once operated, it was very hard to get anything done. So you know, we would try to deploy something, it would fail, we'd have to try again a week later. It was a mess. And so what I want to do is kind of introduce you to why that was and how we fixed it. So going back to the Cardlytics of 5 years ago, so this was two and a half years before I joined the company. Like so many other companies, Cardlytics built monoliths. And by monolith, I mean one or two giant applications that encompassed a lot of functionality that crossed all sorts of bounded domain contexts and that did everything all in one place. So to understand what these two things mean, offer management system and offer placement system, I want to give you a very, very high level introduction to what Cardlytics does. So we're a digital advertising company, but unlike other digital advertising companies, we work with banks. So we're essentially a middleman between a company that wants to run an advertising campaign, someone like a Starbucks, and someone like a bank. So maybe Bank of America, Chase, whoever. And so when we build advertising campaigns, we deliver those advertising campaigns to the banks, and they actually appear in the bank's online banking or mobile banking platforms. So if you're seeing cashback offers today through Bank of America, Chase, or a good number of other banks, that's our technology delivering those adverts to you. So we have these two major pieces. We have the offer management system, which runs at Cardlytics itself, and we have the offer placement system that actually runs inside the banks. What I'm going to talk about today is mostly OMS, the offer management system, because that's the side of the company that I've primarily worked on. The offer placement system has its own set of challenges. As you can imagine, banks and agile practices don't generally mix well together, at least from a software development and deployment perspective. And so that side has its own unique set of challenges. So what did this all look like when we started our journey towards continuous deployment? Well, if you're at all familiar with the works of Tolkien, you might recognize this as a representation of Mordor with Sauron's tower there on the left. And this sort of hellscape really kind of represented what it was like to actually try to deploy software at Cardlytics 5 years ago. Why was this such a problem? So let's talk about what it meant to actually develop our OMS system. One of the problems is that it was maintained by a junior team. And so what this meant was that when you first joined the company as a software engineer, you were typically placed on this team called GSD, or Get Stuff Done, which is also one of our company mottos. So this was a team that you worked on for maybe 6 months, and then after that, with any luck, you graduated to an actual development team. So the GSD team, very junior, responsible for maintaining one of the most complex monoliths in the company. So imagine that, you know, you're an entry-level software engineer, you've just come out of college, you're placed on a team where you are expected with very little experience and no domain knowledge to maintain this big complex beast. But you're not responsible for developing new functionality. Oh no, that falls to other teams. So that means that other teams' work gets offloaded to you on an ongoing basis, but you don't get to build anything new. It's no wonder that everyone wanted to graduate from this team to another team after 6 months of being there. So how did we ensure any kind of quality at all under these circumstances? Well, there was a lot of manual testing. There were some unit tests, but generally low in quantity, low in quality, and they certainly didn't cover anywhere near as much of the product as we wanted to. We tried hiring developers to write tests, so you might call them software engineers in tests, or SDETs these days. But really our experience there was that people who were hired to write tests, they didn't want to just write tests, they wanted to write product code. So again, everyone wanted to get away from this team. No one really wanted to maintain it. Everyone just wanted to write new features. And as we know with a production application, you absolutely cannot treat it that way. So given these constraints when developing the product, what did it look like to actually deploy this thing? So here's your first red flag, right? 10 people in a room required to actually achieve a deployment of OMS. Now, do you need all 10 people there the whole time? Maybe, maybe not. But nonetheless, these were all the people who could have been involved. And so, yeah, you literally put 10 people in a room. We had 2-hour deployment windows that invariably became all-day deployments. Why? Because nothing worked right the first time. So bear in mind that this is coming from a situation where there is no continuous deployment process. All of these deployments are done manually. The really bad thing about these deployment windows is that they involve complete system outages. So as you can imagine, because this is OMS, this is our central system where all advertising campaigns are built before they're pushed out to our banking partners. If OMS is down, we can't build any advertising campaigns. If we can't build any advertising campaigns, we're not making any money. So these system outages have a direct effect on the company's bottom line on a day-to-day basis. So that's hugely problematic. And as you can imagine, that results in a situation where stakeholders and the business in general are very unhappy with every release. And the result of them being unhappy with every release is that you don't get to release very often because the business hates it. So one release every 4 to 6 months. Now that doesn't sound very continuous, that doesn't sound very agile, and it isn't. It's the opposite end of the spectrum. In addition to that, we have this question of, what happens if this deployment goes wrong? So we have to do hot fixes. And this was a regular thing. So as you can imagine, if you have 4 to 6 months worth of development work going into a single release, integration testing is a huge deal. Things are invariably missed. When things are missed, it's very hard to figure out exactly which piece of the system is broken and what you need to do to fix it. In addition, you have this other problem that because you're talking about roughly a 1-day downtime anytime a release needs to happen, no one wants to actually take the system down again for a hotfix. And so this results in this situation where engineers would actually copy updated files from their development boxes onto the production servers and use those to replace files in the application as it was deployed. Now, that's a terrible idea in anyone's book. But it's what had to be done in order to keep things moving, or at least relatively moving. So sometimes the problem's so bad that you don't do a hotfix, you have to do a complete rollback. So this was, again, hugely problematic because you have to, in those days, we would take a server snapshot before the deployment happened, and that server snapshot would have to be restored afterwards. And then you'd retry the next week. Now, and again, that means more outages. So your business is now even more unhappy. At one point, one part of the system was apparently so broken that an engineer actually had to write a script to reboot the machine that part of the system ran on every 15 minutes just to work around the problems. There's no observability, so it was extraordinarily hard to find out what was going on. So when you put all these things together, where does that leave us? As you can imagine, business had very low confidence in our engineering organization, and with good reason. Sure, they can build software, but is that software reliable? No. Can they deploy it reliably? No. Can they do it without business disruption? Certainly not. They hated the OMS releases. They were clamoring for new functionality, but the actual release and deployment process, definitely not fans. And the other problem is that on the engineering side, because of the issues that I talked about with the GSD team and who developed the features versus who maintained the features, there's no real sense of ownership among any of the development teams. If you build the feature, you weren't going to be the one maintaining it. If you didn't build the feature, chances are you were going to end up maintaining it, and you had to spend a lot of time figuring out someone else's code. But you weren't going to maintain it in the long run because it was your goal to get off that team and onto a different team. So no one really wanted to truly own any part of this OMS application. So I said I wanted to talk about the OODA loop. If you're not familiar with the OODA loop, OODA simply means this process of observe, orient, decide, act. It's something that was constructed by an Air Force Colonel, John Boyd, a good number of years ago. And the whole principle is the feedback loop. And so we talked about feedback loops very briefly earlier, but I want to return to that in a more detailed way. We said that we had release cycles every 4 to 6 months. That's a problem. That means a very long feedback loop. Any kind of testing or user bug reports for the system would come in. They would take a couple of weeks to get to a development team. Again, very long feedback loop. The deployment process itself took a super long time. The smoke test took a really long time. All of these mean that you have long feedback loops, which are absolutely anathema to anyone working or trying to work in an agile environment. So obviously this was a horrible situation that absolutely had to get fixed. So let's talk a little bit about where Cardlytics started in terms of actually fixing this this problem. So the funny thing about the way that all this started at Cardlytics is that there was no plan. It was just a vague idea of, we should do something about that. No one ever really said, okay, we're going to move to more towards a continuous integration, continuous deployment process, and we're going to provide you with these tools to do it. Go away and make this happen. Here's a process. This was purely a grassroots effort. Someone's noticed that a deployment tool had been acquired for another product, not for OMS at all, and said, you know what, we should try to leverage that. And so they did. And building a deployment pipeline in one of these deployment tools is not that big a deal. I mean, it can be a little bit fiddly, but it's pretty easy to achieve some rapid results and rapid improvements in your process. And that's what's really surprising about this, that it took so long to get there. Now, if you're focused on your day-to-day work, then we can forgive the idea that you don't necessarily have the bandwidth to stop and think and innovate your way towards this stuff. But sooner or later, someone was able to innovate in this direction. And we reached a situation pretty quickly where instead of that 2-hour deployment window, we knew that a deployment could be done in 30 minutes. So that's not great, don't get me wrong, but that was a significant improvement over where we were before. And with a deployment tool, this also meant that it's repeatable, and that suddenly makes the process a lot more reliable. Because deployments were repeatable, that also meant that we could ask stakeholders to be available at specific times to get the smoke testing done. And so this meant that we could reduce the smoke testing time from however long it took before, I don't recall, down to about an hour. Now, in those days, smoke testing meant touching most parts of the application because no one really knew how much stuff had been touched or changed in the application. So you had to check everything. Again, that's a problem, but that's a longer term problem to solve. And one of the effects of this is that as these deployments became more reliable, we started to get a gradual rise in confidence in the engineering organization from the stakeholders. Super important. The next step, we move towards, well, sort of continuous integration. There's a question mark after this for a reason. And the problem is that, as we know, Agile isn't a set of tools. Agile is a mindset. Agile is the approach that you take and that your team takes and that your organization as a whole takes. So Jez Humble and Martin Fowler have this interesting test for continuous integration. And I'm not going to go through the whole of it, but what it boils down to is that if I ask you, how do you do continuous integration? And your first response is to tell me which CI tool you're using, you're not doing continuous integration. It's what they call CI theater. And this is a lot of where Cardlytics went next. So yeah, sure, they have a continuous integration tool. They have a deployment pipeline. But the CI tool does not make the CI practice. The problem is that you don't think in a CI way. You're not thinking about optimizing your pipeline to actually work with a tool. You're building things around the tool. And this is kind of reflective of a gradually evolving agile mindset at Cardlytics, but it's also evocative of the idea that they weren't there yet. There's still a long way to go when this was introduced. So once we have all the tool pieces in place, we can move more towards actual automated deployments. And a lot of this has to do with how we approach our monoliths as a whole. The important thing with a monolith, to be able to automate and make this a lot easier, make it a lot more reliable, is to split it up. So how do you go about splitting a monolith? I mean, you know, we're probably all familiar with the idea that, oh, we could rebuild the monolith as a set of microservices. And that's a great long-term goal, but that's not a short-term practice. That takes a lot of work, and that's potentially years of work. Instead, what we were able to do was we were able to break out certain components of it. So we automated the database deployment. Now, yes, again here, you know, I'm going to pull a tool out of the air. It was SQL compare, but from Redgate. But what that meant was that we didn't have to have manual database change scripts that had to be approved and scrutinized carefully by the DBAs every time a database change was needed. We use tooling that enables us to generate those SQL diffs automatically apply them to different environments. And that's a beautiful thing, because that means we get consistency between environments. It means we get repeatable database deployments. And it means that if we have to roll back, the inverse of that script can be easily generated by the tooling, and the entire thing can roll back cleanly. So one of the things that we also discovered that we could do was to actually split this monolith down, because although we referred to it as a monolith, there were a whole bunch of separate services that all ran together to make this monolith. So why do we deploy all of those when we're not changing all of them? So again, we use the tooling to break this down into smaller deployable units. And that means that we could have a situation where we only deployed the necessary pieces. For instance, I mentioned earlier the piece that we had terrible problems with that required the constant server reboots, which were our queue workers. And we very rarely changed those. So why do we ever need to deploy them again? Why invite more trouble by redeploying those things? So we reached a state where we could make these deployments much smaller and much faster by only deploying the pieces that we actually had to. Plus, when you have a good, reliable deployment pipeline set up, it means that you can go to this single-click deployment model. Now, that's in some ways a function of the tooling, but it's also important from a repeatability standpoint. One of the keys to success with automated deployment is to make sure that your deployments are repeatable at will in any environment, and that they produce the same results. So a single-click deployment takes a lot of the error out of it. Everything is pre-calculated behind the scenes in the process, and you end up with a situation where you can actually deploy reliably. The other effect of having these smaller deployable units and only deploying the necessary pieces is that meant that all these outages that we talked about, so there's sometimes these all-day outages to deploy a giant monolith, we were able to first reduce and then completely eliminate those. So suddenly the business doesn't have that downtime anymore. This, again, has a direct effect on the company's bottom line because we can still be creating all those advertising campaigns that have to go to our banking partners. We don't have to have the business grind to a halt or say, no, sorry, you can't publish any advertising campaigns today because OMS is down. So this was huge. This reduction of the deployment outage window to maybe at first then 10 minutes, and then we were able to eliminate it completely. So accelerated deployments and testing. We've kind of talked about a lot of the reasons that the deployments were accelerated, but this also enables a lot of accelerated testing. If we can get to a situation where we're deploying a lot more reliably, then we know that we can, and without outages, then we can deploy a lot more often. And because we can deploy a lot more often, we've put ourselves in a position where we don't have to deploy a huge amount of tickets or a huge amount of work at any one time. And the result of that is that after a few iterations of this, the business realizes that they don't need to retest everything just because we change something in one part of the system. They can focus their testing, their smoke testing, on the aspects of the application that we actually changed or that are considered so business critical that they need to test them every time. Once we'd achieved that, it was really important to keep the momentum going. So we achieved quite a lot here already. But now, how do we take that stuff to the next level? So I talked earlier about the idea of splitting the monolith. We might think about using microservices instead of simply breaking apart the components of the monolith. And that's the way that we started to shift. But as I said, this was a much longer term goal. This is something that it can take a couple of years or more to pull apart a big monolith and reframe it as microservices. Plus, you don't want to keep on doing what you've been doing. This is evolving your business in the direction of microservices isn't just about doing a one-for-one replacement of what you've done. It's also about evolving your business as a whole. How do we leverage these microservices in order to actually evolve our entire platform, produce the next generation of our platform? From the product side, that's how you think about it. From the engineering side, we're at the sharp end of, well, how do we actually make this work? And so microservices for us means small services, bounded domain contexts, small tickets. And the idea behind a small ticket is an evolution of what we were just talking about. So you don't want to make too many changes at the same time. Why? Because when you make that small deployment, what it means is that you have a very good idea, if something breaks, of what broke and where it broke, so you can fix it very, very quickly. So this whole idea of needing to roll back and retry the next week, all of that can go away now. You can instead fix things in flight and roll forward instead of rolling back. What it also meant was that one of the things that we tried to do was to get as close to this idea of one ticket, one deployment. Now, this is where we really start to get closer to the whole idea of continuous delivery or continuous deployment. So one ticket, one small ticket, hopefully you finish that, you merge your code, and that goes straight to production, or as close to straight to production as we can achieve. We'll talk about obstacles to that in a minute. We did try daily scheduled deployments as well as a way of getting closer to deploying continuously. This, for the record, is something that I was always somewhat against. I think of it in the same way as a broken clock. It's right twice a day, but 99% of the time, your deployment is either too early because your code isn't ready, or it's too late because your code was ready a few hours ago and you could have already deployed it. And the other potential negative effect of that is that if you know you have a scheduled deployment coming up and you really want to get something out, you may well be tempted to rush your development or your testing and miss something that should have been caught before it actually ends up in a production environment. So we did try that, and it was a good experiment, but in retrospect, I'm glad that that's something that didn't take hold across the organization. So I mentioned earlier the idea that in the bad old days, there wasn't much of a sense of ownership of applications or even the part of the applications among the engineering teams at Cardlytics. So why do we care? Why is that important? It actually means that you actually care about the application, not least because it's yours and you want to show off your work. You want to make sure that the organization as a whole and your customers know that you did the best job that you possibly could of building this thing and caring for this thing. It also inspires this idea of build quality in. So you're probably familiar with that. It's one of the 7 principles of lean. And what it means is that we're more likely to do testing and proactive monitoring, and we're more likely to take steps that minimize the mean time to repair when something does go wrong. And the other beautiful thing about this is that empowered engineers help drive product direction. And typically, we think of product direction as coming from our product organization, from our product owners, from our product managers, our program managers, whoever's making those decisions on the product side. But that doesn't mean that software engineers don't have good ideas that can help to drive the future direction of your product. We're innovative too. And if you have a team that truly cares, that truly owns their product, then they are almost certainly going to see a lot of things that could be done to make it better. Maybe those are technical things, maybe they're performance related, maybe they're things that they could do to make the API interface more consistent with what the rest of the organization is doing. But you're also going to see new product features that will help drive product adoption in the marketplace, for instance. Those are not exclusively the province of a product org. The engineering org can help you with that if they have the knowledge and they have the ownership of the product to really understand what it's doing and what it should be doing. I mentioned that we still weren't at a point where we could really do true continuous deployment. And that's complicated because we have some regulatory obstacles to that. Cardlytics is a public company. As a result, we're in some ways hamstrung by Sarbanes-Oxley. So if you're not familiar with Sarbanes-Oxley, what it means to us is essentially a doctrine of separation of duties. And the way that that's implemented at Cardlytics means that as a software engineer, or as someone who's on the development side, I cannot be responsible for pushing an application directly to production. There has to be a separation of duties there. Someone else has to be responsible for that. Someone has to give it a thumbs up who is not a software developer. So we have audit requirements as well. These are put upon us by our financial auditors who want to make sure that we're doing the right things, that we're observing Sarbanes-Oxley correctly, and that they can verify all of those things. So there's a lot of traceability required here. And finally, we have a set of contractual obligations, not so much with our advertising partners, but especially with our banking partners. As you can imagine, when you work with a bank, you're working with some fairly sensitive financial data. And so our contracts with our banking partners have a fair amount of restrictions built into them in terms of what we can and can't do with the data. And so we have to be very careful about what we do with the data, what we do with the applications. So that's where we stand today. Where do we go from here? As I mentioned right at the beginning of this, no journey is ever really complete in this regard. We've reached a situation where we can do single-click deployments. We've reached a situation where we are fairly close to a one-to-one correspondence between tickets and deployments. And that's great. It feels great. My team last year was able to do, across the products we support, I think something between 200 and 230 releases during the year. Now that sounds great. That sounds like a lot. That's probably 4 releases a week. For true continuous deployment though, we should be able to deliver more than that. We should be able to deliver tiny increments, anything up to 10 times a day if necessary. That's the true goal of something like a continuous delivery or continuous deployment. So how do we get closer to that? Well, one of the things that it's important for us to do is to be able to simplify the developer cadence. We want to make sure that we provide a lot of safety for our applications. And by safety, I mean making sure that we have the correct processes in place to ensure quality, to ensure that the functionality is appropriate to what's being asked for, that it's secure. But at the same time, we don't want to have too much process. We need to break the process down so that it only has the truly important steps. So we're talking about getting rid of our fairly traditional Git flow model and moving to something that's much more oriented towards mainline development. So this is a simple example of what that flow might look like. So you have some feature development branches that exist after release 1.0, and then we have each of those features is merged back into a staging branch. Now, the idea of the staging branch here is that that provides a place for us to test. And when I say for us to test, I don't mean so much in the as developers. I mean more for our stakeholders. So this is, it's called a staging branch. It would go to a staging environment, and that's where we would expect our stakeholders to do their user acceptance testing before we move on to actually pushing this to production. So that PR to production, PR pull request in Git parlance, this is something that we have just been introducing very recently. And the idea here is that it's that PR going to the production branch that actually causes the deployment to production. So there's no separate process anymore. There's nothing that needs to be manually triggered. We can now automatically trigger it through this. But wait, didn't I say something about requiring approvals to satisfy Sarbanes-Oxley? Well, yes, but we have figured out how to get around some of those. And I'll come on to how in just a second. So other things that we want to be able to do, this is something we're not very good at right now, ecosystem-wide dependency testing. So this is, I think, crucial in a distributed systems environment that makes heavy use of microservices. When we deploy a microservice, we've probably done dependency testing in the sense that we've tested it against all the other services that it itself relies on. But what we probably haven't done well is retested all the other applications that haven't changed that rely upon our microservice. And if you think about true integration testing, that's something that is still needed. So this is something that we're actively trying to figure out. But like I say, I do think that for true distributed systems reliability, this is very, very important. I mentioned that we had these approval gates and we were trying to, well, not get away from them, but streamline them at least. Previously, those approval gates were done partially through tickets and partially through pauses in our deployment process that required interaction with our production support department through emails and interaction with our Octopus Deploy deployment tool. Well, that's a waste of time. It slows things down. It requires multiple systems. Audit tracing through it is, well, it's not tricky, but it's more painful than it needs to be. So instead, we're simply moving to a model where that production support approval for deployment is given as part of that pull request to the production branch. So you move everything away from tickets, away from emails, away from the deployment tool, and it all goes into source control. So there's only now a single place where you have to go to audit all of that stuff. Now, this is something that we're really just beginning to do. This is brand new. We've only really started implementing it in the last few weeks. So this is the sharp edge of where we're at with Cardlytics right now. We also need to figure out how to get back to proper build promotion. We had that with our traditional Git flow model. With this new model, we technically speaking don't. We're trying to understand whether it's really a big deal, whether it's all that important. We're not entirely sure yet. I want to get there if I can. I am still concerned about different versions of the system building in different places at different times, potentially producing different outputs. But we don't know exactly how big a deal that is yet. One of the other things, we talked about this a little bit earlier when we were talking about true ownership from the point of view of a team, was proactive monitoring. We've started to build dashboards to monitor Eric, thanks for the question. I'll come back to that in a minute. We've started to build these dashboards that allow us to monitor things in a more seamless way, but we still have a long way to go. We still have a long way to go to understand all our tooling, to make sure that we're taking full advantage of our tooling, and to really make that like monitoring and health dashboards. We really want to make those first-class citizens in our environment. And we also talked earlier about this idea that we don't want to do rollbacks. We're much closer to being able to do that right now. We want to roll forward. Now, ideally, we don't want to have to think about whether we need to roll back or roll forward because we don't want to create bugs. The meme goes, I don't need to write tests. Tests are for people that write bugs. And so we don't want to write bugs. We want to do as much testing as we can. So this is something else that we're trying to make sure that we have good processes around. And finally, one of the other manual pieces that we still have is that when we need a new piece of infrastructure to support a service, we're generally going to our SRE, System Reliability Engineering team, and asking them to stand up something for us. We want to get away from that. Manual pieces of process are things that we don't want. We want to be putting ourselves in a position where all of that can be created or recreated and rolled out automatically. So generally speaking, when I do a presentation, all of my agenda headings have some kind of a meme that at least I find vaguely amusing on the interstitial slide. And while this may be mildly amusing, this one also has a more serious point to it. What did you learn today? Apparently not enough. We have to go back tomorrow. And this is absolutely critical to the way that we think about continuous deployment. I mentioned right up front that continuous deployment is a journey that doesn't really have an end. We may not even know what the end state is. And to me, we are always learning more about the continuous deployment process. We're always learning more about how we can get closer to continuous deployment. We'll always want to go back tomorrow for this. We have never learned enough. But some of the things that we have learned, like the big things that we've learned along the way, and if you're reasonably seasoned Agile practitioners, some of these will be obvious, but they bear repeating. You can't be Agile if your practices don't support it. The idea of delivering value continuously is something that's super important. It's one of those core principles of modern Agile, for instance. When you don't have the practices and the processes and the tooling in place to support actually being able to deliver that value, let alone continuously, there's no way that you can continue, that you can consider yourself Agile. I mentioned the OODA loop from the point of view of thinking about everything as a feedback loop. Every process you have, you must eye critically. You must say, what can I do to shorten this feedback loop? What can I do to get feedback more quickly so that I can act on it more quickly? If I'm going down the wrong path with this, how do I stop myself going down that road as quickly as possible? And let's also go back to the very first statement on the Agile Manifesto, this idea that we value individuals and interactions over processes and tools. Everybody remembers that, but what we don't actually always remember is that what the manifesto says is that it's not that processes and tools don't have value, we just value individuals and interactions more. Now, how much you value processes and tools may depend on your organization. We have a fairly regulated environment. We are a public company. We have Sarbanes-Oxley considerations. We have banking partners that are very strict and very conservative about what we can and can't do with our data and our applications. And so for us, those processes and tools do have significant value because they provide us with the regulatory support and the necessary auditability for what we do to keep all of our partners satisfied. So finally, I just want to pop up the typical modern Agile wheel. And I want to think about each of these statements and how continuous deployment practices support it. So make people awesome, that's the very first one. Making people awesome, we usually think about, and in fact, modern Agile typically describes this as talking about your stakeholders, your customers. And that's true, but it's not just them. This is about making your engineers awesome as well. So we make engineers awesome by taking some of the drudgery out of their lives, letting them be the innovative, creative people that they can be, and letting them do the absolute best they can for our products. And by virtue of that, we end up with a team that hopefully cares, that hopefully truly owns their product. And that is then reflected on the quality of their output. And that's how we end up making our customers awesome. So experiment and learn rapidly. We've talked about the importance of feedback loops. Again, if you can't get quick feedback, you can't do effective experiments. You can't learn rapidly. You can't iterate. So continuous deployment, again, whether you're talking about deploying to a staging environment, whether you're talking about deploying to production, super important to get that rapid feedback. Making safety a prerequisite. So this is again, to me, this speaks to the idea of good, solid team ownership. safety for the product. So that means security. It also means psychological safety for our engineers. Psychological safety, super important. That's what allows us to fuel a lot of those experiments that we just talked about. If you feel that you're going to be punished for experimenting and not being successful in that experiment, you're much less likely to experiment. And so that has a chilling effect on innovation. So safety isn't just about the quality of our code, the security of our code. It's also about the psychological safety of our engineers and how much we can encourage them to experiment. And that's not just with new code features or new product features, that's also with new deployment practices. And finally, when you combine all of these, we end up with this idea of delivering value continuously. Without continuous deployment, you can't deliver value continuously. Without many of these tools and processes, you can't, well, sometimes you can't even deliver value. Go back to the very beginning. How much value did OMS deliver 5 years ago with one deployment every 4 to 6 months that was extraordinarily painful and made the business angry every time? So I just want to give you a couple of resources, and these slides will be available in PDF form afterwards. I'll be uploading them to the Slack channel. So don't feel the need to copy these down or screenshot this. You will have access to these. Martin Fowler and Jez Humble both have some very good takes on continuous deployment. Martin Fowler calls it continuous delivery. There is technically a difference between continuous delivery and continuous deployment, which is that continuous deployment actually implies an automated push to production. Continuous delivery stops short of that and makes the deployment to your final production environment manual. But nonetheless, these two concepts are very close to each other, and both of these are a very, very good read. Susie Prince is at ThoughtWorks. She talks extensively about CI theater, so I referred to that earlier in the talk. And a couple of wonderful books as well that I highly recommend to everyone. Continuous Delivery is probably a little more on the technical side, the Jez Humble and David Farley book. Accelerate, though, I think is applicable to anyone in the Agile space, whether you're on the technical end of this or not. And that's by Nicole Forsgren, Jez Humble, and Gene Kim. There are some Amazon links there for you. Thank you for your time today. My contact details are here on the screen. I think Kevin is also putting my LinkedIn information into one of the Slack channels, or maybe into the Zoom chat. Please feel free to reach out with more questions. I think I have 5 minutes left, so we can try to look at some of the questions that have come up in the chat. But if there's anything outstanding, please feel free to either email me, contact me on LinkedIn, or put it in the experience report channel in Slack, and I will do my best to attend to those after the session is done. All right, let's see what we got. So Eric says, how does one empower engineers? So empowering engineers to me is about, at least in part, it's that modern Agile principle that I covered a moment ago. There's making safety a prerequisite, and this is the psychological safety. In a culture that punishes failure, engineers will typically not innovate. They will keep their opinions to themselves. They will step back from innovation, and they will just take the safe course through things. We want to encourage them to experiment. We want to encourage them to try things. Now, the other aspect of safety, as I mentioned, is this idea that you want to make sure that you're delivering something that's high quality. So if you are experimenting, you shouldn't be experimenting in a production environment. You should be experimenting in a lower environment where you can prove out your concept before it goes any further. But providing engineers with the time and the space to do that, I think, is critical to advancing your organization. Another concept that reinforces that, and this is a resource that I didn't put in my resources list, but I do want to mention real quick. There's a book by Tom DeMarco called Slack, and it has nothing to do with the Slack chat application. It's all about the concept of slack time. And what he stresses is that if you insist on 100% utilization of your team, you will never break the status quo. You must give them slack time. You must give them time to step back, to think about what they're doing in a meta or holistic way, and to actually have time to mentally innovate. And not just mentally innovate, but what I mean by that is if you haven't thought about what you're going to do to improve the situation, you can't even begin to act on it. So empowering engineers is giving them enough time and space to innovate, making sure that they're not punished for experiments that fail, and putting them in a position where they can actually affect the course of things. I talked about the idea that empowered engineers can help drive product direction. I think that that's crucial. Show me that my input makes a difference, or that it made a difference to your product or to your company. That is what gives an engineer a sense of achievement. It's what makes them want to do more of the same.
Hey, Francis, just real quick with the last minute, we have your customers and banks reacted positively to your faster deployment, or have they been resistant? And do you use feature toggling for some customers that don't want or aren't ready for the new stuff?
So one thing that I want to emphasize here is that the products that I've been talking about at the moment are more what we consider advertiser facing. So I said that I wasn't going to talk about our offer placement system, which has its own unique challenges. Our banking partners, so we are trying to accelerate the stuff that's bank facing as well, and we are finding that they are reacting positively to that. They all want the new features, but they don't want to have the expensive testing cycles that those rollouts to banks require. So yes, finding ways to innovate around that, finding ways to actually deliver their new features faster, they're absolutely reacting positively. We do use feature toggles extensively, and that's not just for bank-facing stuff, that's also for advertiser-facing stuff. So we use those fairly extensively to be able to deploy certain features dark when necessary, if the rest of the system isn't ready for them. So yes to both of those. Thanks for the question, Alex. I think that's all time. Yep, I think that's all. That's everything we have time for. So thanks everyone once again.
Awesome. Thank you all.